on to our final presentation. Tom mentioned induced seismicity, and I talked a little bit about that. Well, Seth Carpenter in our Geologic Hazards section is going to tell us a little bit about a project we've started in Eastern Kentucky to do some baseline monitoring of microseismicity. Thank you.
So Dave mentioned a little bit, and mercifully I will try to keep it to a little bit. I know I'm competing with lunch, and I don't want to take up that challenge. So anyway, I am going to talk to you today about our project that's ongoing. We introduced it last year, and it turns out that it is working. So I hope you caught it last year for some background, but I'll push through that a little quickly. I do want to give some acknowledgments at first. Of course, KGS for their enthusiasm and support, and even a lot of sweat from a few people. But also the Earth and Environmental Sciences Department at UK, including probably some blood from Andrew Holcomb, his contribution. But also some partners to the project, including private industry, which makes this kind of novel, and as I understand it, maybe the first of its kind, where we've brought in Nanometrics and Cimerex Energy, to be partners on the project. And then, of course, we wouldn't have a network without landowners. So here's the outline. I'll just move through that. And here's the issue, which I'll just briefly give you a picture of with this map. As Tom just talked about, there are operating Class 2 injection wells. These are saltwater disposal and recovery wells in Kentucky and throughout the U.S. Many of those have been associated spatially and temporally with earthquakes, and that's the issue that we're looking at addressing. So the yellow dots are the locations of those wells that have occurred in time and space proximal to earthquake activity. And now the reason why I can show you this map, there's a lot of funny things about this correlation. It's a weak correlation, but I think anyway. But nonetheless, something about it is telling us the truth, because this black line here is the difference between the total number of earthquakes that have been observed and those which are associated with wastewater injection activity or enhanced recovery activity. The black line should remain constant for natural tectonic processes, and it is. So that's the issue. So what about Kentucky? And that's been raised in numerous articles. Folks have asked the question, and so of course KGS is responding to the question in like kind by initiating a project in eastern Kentucky focusing on the Rome Trough. So Dave and Tom have both set up for us the setting for that issue. So what's the purpose of the project? Well, it's to collect new data. That's our primary goal. And the purpose of the data is to give us an assessment of the background seismicity, the naturally occurring microseismicity, which means small and typically experienced by people. Also to determine if any of that activity could be associated with ongoing injection or production wells in eastern Kentucky. And then as we see these events, we'd like to be able to discriminate between the natural and the man-made. That takes a bit of work. So the partnerships that I mentioned earlier, we've brought in Cimerex Energy, which is the company, as Dave mentioned, that is responsible for a couple of the deep test wells in eastern Kentucky. And this, I'd like to commend them for participating in this, because that's bold. That's a bold move with a polemical topic, especially because of the potential for being associated with earthquake activity. So they are interested in being open about it, and which means they can work with us, and they are doing so. Also, thanks to the EES department for graduate students, as well as helps with instrumentation purchases, and also Nanometrics for technical support and instrumentation as well. So here's our setting. I'll build it up for you bit by bit. The purple triangles are existing seismic stations operating in the vicinity of our project area. Orange circles are historical earthquakes. Of note on here is the magnitude 5.2 1980 earthquake in Sharpsburg, just north of the Rome Trough, which caused a good bit of damage along the Ohio River. And also to the south is the northern reaches of the eastern Tennessee seismic zone. So this area has known earthquakes in the past. These are the wastewater injection wells, which are operating. I do not have enhanced recovery wells on this map. And then these are the locations of the deep test wells that have either already been completed or are permitted in eastern Kentucky. And there's our monitoring network on top of this framework. The red triangles are the stations which have already been installed and are running, and the yellow triangles are stations that are in the works. I want to focus on this area a little bit with a neat map up next here. Again, different symbols, but these squares and circle are the test wells targeting the Rogersville shale in eastern Kentucky, and the blue triangles are now stations. And so let's look at something interesting on here for timing. You saw this image earlier from Dave, Google image, so satellite view of a well pad, which is in the works in eastern Kentucky. And notice the date here. We heard that this was going to go in, and so we, on the same day, are just a few miles away here installing a seismic station. So Google caught us in our action as well as they caught Chesapeake in their action. So, but we beat it as far as I know. So the purpose of the network, again, you understand that the status is that we have 12 stations operating, hopefully more on the way. We're doing real-time analysis of the data, and we're simultaneously acquiring data in real time from surrounding and pre-existing stations. And we're doing real-time locations. First findings, we have seen 7 earthquakes, at least in the area of this map. 19 additional earthquakes within about 200 kilometers radius, and 1 within the Rome Trough out of all of those. Now that earthquake was in the West Virginia Rome Trough, so none within the vicinity of the injection wells or the deep test wells in eastern Kentucky. And then of course we're seeing lots of blast evidence that there is ongoing coal activity in eastern Kentucky. And that's illustrated by this map for us. On this map, stars are earthquakes, local earthquakes, and then the orange circles are the locations of mine blasts that are ongoing. So this is an output of our real-time system, which a visiting scholar from China helped us to install. And we're seeing lots of activity, mostly of the man-made kind, related to coal mining. These maps give us a picture of what we've seen in the local area. This is the historical picture. For now, just pay attention to the orange dots. Those are the historical earthquakes. Over here, these are the ones that we have located. And you'll see that there's some differences. For example, down here, south of Moorhead and closer to the Rome Trough, there's some activity that has escaped the historical view before, as well as up closer to the Ohio River. So we are seeing natural earthquakes, and albeit they are micro earthquakes, they're quite small. But let me focus on these two a little bit and show you what we can do with this higher resolution study. First of all, we have some beautiful seismograms, and that makes us seismologists very excited. And for this example, it's a magnitude 2.1 earthquake, yet we see really high quality data out to maybe 50 miles away. And using that high quality data, I'm going to give you just a taste of some of the things that we can do. First of all, without our project data, these are uncertainties. So you might call those the error in the locations. Now this, of course, is a very important parameter when we're looking at understanding if earthquakes are associated with ongoing injection or production activity. So without our data, this is the best that could be done in terms of the error. About almost 5 kilometers in depth. Z is depth, and 3 kilometers horizontal error. With our data, we're doing much better. We're able to divide those by about a factor of 3 in terms of the improvement in uncertainty. I'll explain the beach balls momentarily. For another event that was north of the Rome Trough, you can see that without our data, there's a tremendous amount of uncertainty, particularly vertical. And again, we improve it by at least a factor of 3 with our network data. So these are very important quantities to keep in mind when we look at associating events with ongoing injection activity. Now, those beach ball looking things here are tell us the style of faulting. So because of the high, this is unusual to have such high resolution data, where now we can actually look at the kind of faulting that's happening in the vicinity of the earthquake location. These circles on here kind of graphically show you the differences in the uncertainties in the locations around these earthquakes. 1 and 2 here. Red is without our data. Yellow, which basically lies on top of the beach ball itself, is with our data. So we're doing very well. But also we can see that this kind of earthquake activity here is predominantly strike-slip with a component of thrust, and predominantly thrust with a component of strike-slip. So anyway, there will be, hopefully at some point, interesting understandings about the geological framework that will come out of this. And what's also interesting about this is that those earthquakes show a style of faulting that is consistent with the background and regional stress. So there will be tectonic, hopefully we will have some tectonic interpretations eventually. out of this study. So in the end, we're anticipating that increased oil and gas production in Eastern Kentucky has the chances of increasing felt seismicity. Not necessarily, but nonetheless, that gives us reason to conduct this study. So along with our partners, we're working to indeed establish background levels of natural earthquake activity, monitor low-level induced seismicity if and when it occurs, and then again work on discriminating between the natural and the man-made events. So the project website is up there, and please feel free to contact me with further questions. So, thank you.